In the final revision video, we will be solving simultaneous equations, or also systems of equations, systems of linear equations only. And there are two ways how we can solve this type of question, either graphically. If we are given two lines, we can graph them and find the point of intersection. We can use our calculators to graph those functions and thus find the point of intersection, or we can solve the system of equations algebraically, and that's what we're going to start with. So, looking at the two equations we are given, it's always a good idea to somehow label the first and the second equation. I have two variables and two equations. And looks like both equations have a coefficient of y equal to 0. So we have methods, we have two different methods of solving this sort of question, and it was substitution method or elimination. If you don't remember what these were, go to the book or find the videos on Khan Academy or take a look at your notes and make sure that you understand both of these, because in some cases one of them can be more suitable than the other. But at the end, if you know how to use one, you're always good to go. So in looking at the first equation, I can isolate y, so that I have y is equal to, and since I am moving these 3x and 6 on the other side, I would have minus 3x plus 6. And the second equation, I do the same. I isolate y. This time I have plus x plus 2, or just, we can write just x plus 2. And I will use a substitution method. This is a special case when I have an expression for y as x plus 2. And since I am looking for the point of intersection, this y must be the same as this y and x the same as this x. So I can substitute this expression x plus 2 for y. So I will end up with x plus 2 is equal to minus 3x plus 6. And now I have only one variable, x. So it's a simple linear equation. I add 3x to both sides of the equation. 4x plus 2 is equal to 6, and I subtract 2. So 4x is equal to 4. And now I divide by 4. So x is equal to 1. We have one reason to celebrate, but still we need to substitute back in order to find x. So now I will use that I know what x is, and I will plug in x to the expression for y. So from here, y is equal to x plus 2, so my x is equal to 1, 1 plus 2. Y is equal to 3. So my solution and there are more ways how to write it. We can again use those curly brackets, that x is equal to 1, y is equal to 3. And I mentioned graphical solution. So I'll just sketch very quickly what these lines look like. get rid of this so that I have more space. So I will use the slope-intercept form, so these two, and I have y-intercepts 6 and 2, so I will be good with the positive part of the coordinate plane. If this is my 2, this will be 6, and the first line has the slope -3, so it will be decreasing. So I'll just sketch it, and -3 means that for every 1 step to the right I go 3 down, so 6 minus 3 would be somewhere here. So this is my first line, and now the second line, it crosses y-axis at 2 and the slope is 1, so for every 1 step to the right I go 1 up. So for 1 step 1 I go 1 up, and this point, and we could actually see this 3 as we were evaluating the slopes. This is that point of intersection we got here. Yep, so this is the solution, graphical solution to the system of equations. The second question on simultaneous equations looks a bit more challenging. I have x, y, and a parameter a, and the question is, for which value of a, so this parameter a, does the following system of equation not have a solution? So the system of equations does not have solution if the lines are, or the two lines don't have an intersection point if they are parallel. So lines have to be parallel. Again, it's a very complex question. We need to combine what we know about parallel lines, that they have the same slope. So we need to find what a must be so that these lines have the same slope. So these two lines must have the same slope. So let's take a look at the first second. My first line, the slope-intercept form starts with y is equal to something. So y is equal to, I had 7y originally, so I need to divide by 7. And also, slope is the number that is a coefficient of x, so be careful here. And maybe I should also include the negative sign. This is the slope, -21/7. So I will rewrite the equation of this line in that order, the official slope-intercept form as -3x plus 5/7. And as for the second line, this looks a bit more complicated, but let's see. Again, I will try to isolate y, the term including y first. So I need to move 12x on the other side, so -12x plus 19. And now I need to divide by the coefficient of y. So y is equal to, I don't know what it is. But now the slope is this value. And I want the slopes to be equal. I want to have the equation of y is equal to negative 3. I want to have the equation negative 3x plus or minus something if a would be negative. So what must a be? So negative 12 over a is supposed to be equal to negative 3. Now maybe even without some algebra, what do I need to divide by negative 12 so that I get negative 3? Yeah, this must be 4 because negative 12 over 4 is equal to negative 3. Yeah, so from here I can conclude that a is equal to 4. And maybe we can check, because there could also, the system of equations can also have an infinite number of solutions, and that would be the case if I had two exactly the same equations. So if this equation is y is equal to negative 3x plus 5 over 7, if I had the same, exactly the same equation here, then the lines would be coincident. It would be one line. But if I plug in here 4, 19 over 4 is not equal to 5 over 7. So I'm safe there, and for a is equal to 4, the lines are parallel, hence the system of equations has no solutions.